Welcome to an Achieving Science video. This video is going to cover fluid pressure. Let's start off with a question. If we look at the bottom diagrams, which one is correct and why? Each diagram shows a cylinder of water filled up to the top. On the right hand side there are three equally sized holes. Is A correct, which shows the water from the top hole is projected the furthest? Is it B, that it's actually the bottom hole that projects the water the furthest? Or is it C, each one will project water in exactly the same way? Let's see during the video if we can answer this question. First of all, let's deal with the term pressure. Pressure, this is the force that is applied to a surface. This can be defined as the force exerted per unit area. The second term is fluid. Fluids, these are substances that can flow. From your previous knowledge, you know that solids have particles in a fixed position, so therefore the particles cannot flow. This means that fluids can be liquids or gases. We know also from our particle knowledge that each particle has a mass. Therefore, as a particle hits a surface, it will exert a force upon it. Now let's move to some maths. There is an equation for calculating pressure. The equation is force divided by area, where force is measured in newtons, area is measured in meters squared, and pressure is measured in pascals. So therefore pressure is affected by both force and area. The bigger the force, the bigger the pressure. The bigger the area though, the smaller the pressure, because we are dividing by area. So the bigger the number of area, the smaller the pressure becomes. Now let's look at this scenario. On the left hand side we have a force being pushed down onto a piston, which applies a force to a liquid. This then exerts a pressure onto the area 2, a second piston, which then pushes that piston upwards with a force of F2. If the question asked you what the size of F2 was, and it gave you the following numbers, could you work it out? So the force applied to F1 is 1000 newtons. The area of piston 1 is 10 centimeters squared, and the area of piston 2 is 40 centimeters squared. Now if we plug all that in, we can actually work out the force that is exerted by F2. Because we know that pressure equals force divided by area. Well, here we know the force exerted on piston 1 and we know the area. So therefore we can do force divided by area, 1000 divided by 10. Please note, I haven't changed this to meters squared, just to keep my numbers easier to deal with. I don't have to change it because the area of piston 1 is measured in centimeters squared, which is exactly the same as the measurement of piston 2. Therefore, if we do 1000 divided by 10, we come out with the answer of a pressure of 100 newtons per centimeter squared. Now, if the pressure here is 100 meters per centimeter squared, it is throughout that liquid. This means that on piston 2 the same amount of pressure is exerted. Therefore we now know the pressure and we know the area, which means we can now plug that all into our equation. We can therefore now rearrange this equation. If we divide the force by 40, that means if we multiply the pressure by 40, we can generate and work out the force F2. So 100 times by 40 gives you an answer of 4000 newtons. As you can see, 1000 newtons has increased to 4000 newtons. This is therefore an example of a force multiplier. This could be used within the braking system of a car. Pressure in liquids then. How close particles in a liquid is very important. We call this density. Therefore, higher density liquids have more particles per unit volume and therefore exert a greater pressure due to there being more collisions against the walls of the container. Density then, for a given liquid we say the density is uniform and does not vary with the shape or size. We have an equation where the pressure is related to H density G. H stands for the height, measured in metres. The density is measured in kilograms per metres cubed. And G stands for gravitational field strength, measured in newtons per kilogram. Again, pressure is measured in pascals. Let's use this to work out a calculation. So can you calculate the pressure at a point 30 metres below the surface of the water, where the density of the water is 1,000 kilograms per metres cubed, and the gravitational field strength is 9.8 newtons per kilograms? If we plug all those numbers, we can work out pressure equals 30, the height, times by the density, 1,000, times by the gravitational field strength, 9.8. We can work out the pressure is 294,000 pascals. This can also be written as 294 kilopascals. Secondly, can you calculate the change in pressure between a point 15 metres below the surface of water to one which is 30 metres below the surface of the water? First of all, let's work it out the pressure at 15 metres. So the height is 15, density is 1,000, G is 9.8, which works out at 147,000 pascals. If we do the same for the second height, 30 metres, so height is 30, times by the density 1,000, times by G 9.8, we have an answer of 294,000 pascals. Therefore, it's asking for the change in pressure. So it is changed from 147,000 to 294,000. What is the change then? We need to subtract one from another to work out the difference. The change is 147,000 pascals, or written as 140 kilopascals. Atmospheric pressure. This is created on a surface by the air particles colliding with the surface. As we move from the surface of the Earth away, the atmospheric pressure decreases. As we move away from the surface, the density decreases as there is less air particles.